Welcome to another episode of Breaking into Cybersecurity. Today, I have my good friend and mentor, Mr. Jon Salisbury from Nexigen, and he holds one of the new and distinct titles of Chief AI Officer, and he's going to tell us a little bit about what that is and how he got there, but I'll let him introduce himself.
Chris, thanks for having me on, first of all. And you're a mentor of mine as well, my friend. So that's called friendship right there, in my opinion. And I met you, what is it, back in, it's only been like 2 or 3 years or something like this online. And you're a prolific writer and you share information and you're always trying to help other people. And I just noticed it through your authenticity and curiosity. And it's attractive. It's like gravity, I think, just brought me in your orbit. And it's been so much fun interacting with you. And then you have helped my organization, and you're so technical and so smart. And thank you so much for having me on. So yeah, I'm Jon Salisbury. I'm the co-founder of Nexigen. Who is that? It's not like Amazon where everybody knows your name, but we were founded in 2003 as a competitor. It's a technology company now, but we were founded in 2003 as a competitor to VMware. And VMware was founded in 2003. I think they were funded with $250 million. And my business and partner and I, we put $500 in each. And we built we were so young, 22, 23. And we were like, let's try to, we realized that processors were, whoever had the most processors and the most amount of compute would win. We both were fans of Ray Kurzweil. We looked at the projections and we saw, man, like computation is super important. And then also the inefficiency in computation is tremendous. So people at the time were like using Pentium 3s, Pentium 4s, which are like early Intel processors for their desktops. And then they were using what's called Xeons for the servers. And the amount of processor that was actually being utilized versus how much was available was incredible. So back then they didn't have virtualization. You couldn't run multiple operating systems on a processor. So we built a virtualization stack on our own, which allowed us to basically put multiple operating systems on a processor to leverage the remaining excess capacity of the processor. Now, our system was built with $500 each, and we leveraged as many tools as possible. And we built what we called a utility computing environment. We used Systrix, a company called Sparse, which ended up becoming Hyper-V, as well as our own kind of tooling and stacks to kind of stitch this thing together. And then we would put rows of these Pentium 4 desktop computers next to each other and then bring people in and then just load them into what was available and then charge them for memory, processor, storage, and so forth. And we built a really killer website back in '03. So we would get calls from like GE, General Electric, and we would get calls from these like big companies, like you're doing like utility computing. And we're like, yes. And then they would come down to our office, which is now a like small tattoo parlor on a little like river city in Northern Kentucky. And they would say, you kids are not even, you're doing really cool stuff, but you're not even like ready for General Electric. So we ended up changing by demand from our customers into a traditional technology company. So they're like, hey, you obviously know what you're doing. You're very innovative, but you're like too innovative for us, I guess you could say. And that's basically a startup. And then they would say, could you just sell us a server? Could you provide us tape backups? Could you put that on a maintenance plan? Hey, if my people don't know how to use a computer, can they call you? And then can you build us a website? Can you host a website? And all these kind of things. So from there, Nexigen was born. The name Nexigen is built off a Latin word, which we thought was really important to have a really good name. And then we did all this analysis on companies that were successful. And we found that Latin name companies were, for some reason, more successful. So we found the word exigent, which meant like speed and expedience or urgency. But we tried to logoize it, and the T at the end of exigent just didn't look right. So we got rid of that, and we're like, it still isn't balanced. Let's put an N on the front. It looks like next generation. And then we came up with our own word, and that's how we were born. Now, since then, we have launched 15 companies. We've had 6 failures, 2 exits, and we have 7 active companies today. Around 220 people work across our organizations. Nexigen itself has around 85 people. And Nexigen itself now does the following. So our goal is to be the ultimate IT service department. So your ultimate technology partner for all of our customers. And because most companies don't have everything in-house, So we want to just have everything you could possibly need available to us to use a la carte, fractionalized, or fully. So we have certain organizations that are small businesses that they do everything. We do network operations, we do help desk, we do cloud services, we do cybersecurity, we have a SOC, we've got a forensics department, we've got a ton of different activities over there. And in 2022, when ChatGPT came out, and one of our companies precursor to this in 2015 started as a smart city company. And I helped create a standard called the P2784 IEEE Smart City Interoperability Standard, which was a program to basically help smart cities take all of the disconnected data sets and bring them together in a formalized way to then bring it all the way up to analytics and to artificial intelligence. And back then, deep learning systems were going crazy at DeepMind and Google. And we were seeing that AI was basically going to take over. And we were very much on that. So this smart city company we have makes 8-foot tall iPhones. It builds infrastructures into city streets and venues across the country. And then from there, we take in a lot of data. We interact with a bunch of users, and then we do advertising and all these other kind of add-ons and widgets that we've built to be helpful in cities. So,
Wow.
hitting
First
the
of all,
nail- yeah,
congrats on the agility and the innovation to be able to keep up with the changing industry and to keep up with demand. I think one thing a lot of founders struggle with is they have a vision and they just want to deliver on that vision and they don't know when to give up, when to evolve, and when to sunset a product. So congrats on that and being able to admit that, hey, it might have been successful 10 years ago, but the industry, the technology has changed. We need a new way to solve this problem, and let's go ahead and create that.
you got to get rid of your ego. Like your ego is just getting in your way. What is happening? Am I actually listening to my customer? What are they telling me? Am I hearing the same thing over and over? Okay, there's a problem and it's repeatable. Let's solve that problem one time and it solves it for everybody. And then the vision piece is projecting. And once you get enough experience in your solution space and your mind is wide enough, you can start combining and creating simulated projections. So in 2022, when Gen AI came out with ChatGPT, my mind was on fire seeing all of the projected outcomes that were going to come. And honestly, my first thought was, okay, you like in Nexigen, we start every Monday off. We did it this morning. At Nexigen, it's God first or self, whatever you, there's no stigma there or anything or any judgment, but it's God first or self. Second, it's family. And then third, it's work in that order, without question, without hesitation. That's how we treat every single individual. So if you're struggling individually, and you're hurting, we'll jump in and send you life preservers every which way we can. And then once you get back on your feet, you're cranking. And I see people do this typically. So that's number one. But when it hit me, I did the same thing. Okay, how does this affect me? How does this affect the world that I'm in? How does it affect the people absolutely closest to me from a proximity standpoint? And then how does that then ripple out into the world? So we created an AI research lab. And what the hell is that? And that's how I became a chief AI officer, is really through knowledge. So I knew I'd played with neural nets. I'd played with some deep learning systems. I'd definitely been a user of them from cyber and the different technologies at like Azure and AWS and so forth. But I'd even played with some analytics, but I'd never built it from scratch. I'd never built a deep learning model from scratch. I'd never
Mhm.
taken data, combined it, created the recipe and I'd never been the actual chef. Right? And a research lab, that's what you have to learn how to do that. So you have to be able to make models from scratch. And that includes neural nets. That includes, we create genetic fuzzy algorithms where we grow evolutionary systems. And those are causal models. And then we also play with all sorts of different kind of models and we integrate them together. And then we try to learn from the inside out. So we want to learn how the data formulates together, how the mathematics brings that data interaction or assembles the system together, and then how that then produces the outcomes you're looking for. So I consider that model engineering and data science kind of blended. And that I went back to get my PhD, or I'm working on my PhD. I'm taking PhD classes. And then from there, I felt comfortable giving myself a chief AI officer. Now, in reality, a chief AI officer is more like a CIO that works on data. They're not model engineers. Typically, they're not
Mhm.
technical. They're more business focused. They're trying to navigate. They're more strategy. I definitely take a more of a CTO type of position in this chief AI officer role, and I'm also the CEO and co-founder. Now, eventually, I will hand that title off to someone that comes in to be our chief AI officer at Nexigen. But right now, I hold it typically on the front end, and I try to do that from a leadership standpoint. In fact, I did that with a CTO position, and then I didn't want the title CEO even as founder because I feel like a CEO is all they do is cheerlead. And I like cheerleading. That's something I guess you grow into. But I also like getting my hands dirty enough to where I can go to deep in conversations, architects, and get into where I'm actually able to build. So I hold dual titles right now, and that's my journey. But I would say that's not typical. Most journeys are going to be definitely from the data science side or from the development side, which we have had a development company, and I have done development work. That's typically like a really straight path up there. Mine's very like all over the place.
Over the years, we've had some interesting conversations about mimicking nature and taking the lessons learned from nature to see how we can blend that into compute and algorithms. How are you using that to help evolve AI models today and make them more efficient?
So cool. Okay, so we got a few really cool projects. I can talk about things very generally, but we have some very specific things. So in the research lab, we're partnering with universities. So universities right now do research, so do research labs outside. And research is different than product development. So product development is way down the road. Research is like 3, 5 years out. So with these universities we're working with, we attach with them and we work grants together. And those grants you're then working on potential military application. And things we're working on are such as like drones are a big issue, fully autonomous. So drones are coming into the world. And theoretically, this is just like hypothetical, you could pull a boat up to the side of the United States and release 500 drones with like major tactical munitions, so like missiles. And these drones are basically identified through their RF signals. So they have to check back home to be controlled. So they have central command and control. And today, with generative AI or with these new types of models, you can now have, or you're getting the capability where you can have autonomous drone systems that can fly, take out missions on their own. They don't need to check in. They're fully open. And cities are completely unprepared for this. So, one, you need radar in place in order to detect these things. And you have to have precise radar because these things aren't huge. They could be relatively small. Secondly, they have AI models running them and autonomous. So you can't disrupt them. You can only destroy them. Now, there are ways that we think that there's ways to interact with this. So in nature, I was looking at also your existing inventory that you would use for defense, which would be your own drone system or
Mhm.
anti-drone system or anti-missile system, similar to Israel has with their like shield that basically shoots down missiles that come in or drones that come in. You basically have to detect as number one. Number two is respond. And then three is now that you have your drones, you have models that can be jailbroken. So these, I call AI models more like advanced Excel sheets with macros. They just are when you do the math and on so when you're looking at gradient optimization and you're looking at some of the other like Atom, which is like a acceleration algorithm, or some of the other ones that we like genetic fuzzy, which is there's a ton of I could walk you through how they work and blend, but they're really like macros that are automated. And you can jailbreak them very easily by just tricking them and slipping into kind of like the math where it just they build guardrails, but the guardrails aren't very robust. You find cracks and then you can sneak through the cracks because the math doesn't fit together properly. So you're just there's cracks everywhere through the system.
'Cause
So if you
they have to be really efficient to be able to run A, low energy, and B, make split-second decisions, like as a swarm, one drone versus the whole swarm, make these decisions.
That's correct. Okay, so you have that's what I would call solution space. So you have like chess engines, like AI chess engines. Now, AI chess engines are you can run on your phone and they can beat any human in chess. They're unbelievable, like Stockfish and so forth. Now, you when you reduce the solution space size, that's basically reducing the data distribution set. So the data distribution set is very focused, and then you can grow your algorithms based on a couple ways. One, you can do it genetically where it just finds its own algorithms based on self play. The other way is you can basically take expert human knowledge and then you can port it over. And that's called injecting meaning into the model. So you're creating human alignment through algorithms. Now, I like that because it gives you a causal interface, which means that you have a cause and effect and you can explain why things are occurring. Now, with drone systems that, like, if you have your own system, you can get jailbroken. So a lot of these systems are hallucination prone, and they're also, you can basically zombify them. You can basically inject jailbreaking. You can take over the mind. Now that mind becomes yours. That AI Excel sheet's yours. Now it can then infect other Excel sheets, and all these Excel sheets now become yours. You even slave them right in this process. So where does that occur in nature? And it does occur in nature. So you have termites and fungi.
Hmm.
Fungi currently, termites go out and they basically are exploring nature, and they have these termite. If you watch an ant like very closely, they have method to their madness, and they work independently, and they call this an emergent property. So you have one ant and it's moving around. You put your hand here, it avoids your hand, it finds the perimeter of your hand, it moves around it. It still wants to get to its objective, whatever its objective is. It was sent it and navigating that direction. Now, when you do that in synchronous, like 1,000 of them are working together, the pattern changes and a new pattern emerges through complexity of them working together. And that's called an emergent property. Now, what happens is when ants go out exploring, though, these fungi can attach to the brain of the ant, and they can actually enslave it, and they can actually get the ant or termite to do what it wants. So the ant becomes an enemy of its own tribe. So the ant then comes back to its own tribe enslaved, and now its spores can infect the rest of the ant spores. So all the other ants can be enslaved. What happens is if this occurs is it can wipe out an entire ant colony. Okay.
Is
Now,
that because the ant might attempt to kill the fungi, so this is their defense mechanism?
I'm actually, that relationship is, I haven't studied that as much, but it does exist. The fungi in general, and it's a very diverse ecosystem of fungi. You have hyphae interfaces, which are based in mycorrhizal interfaces. Hyphae are like the strings that go out. Mycorrhizal interfaces are like the connection from the hyphae into the plant it's trying to interact with. Then you have spores, which are then on the molecular level, which is like below that. Spores, like on like psychedelics, for instance, they
Mhm.
can go right into your neural structure and attach to your neurons, and they can reorder human neurons, right? But think about that in a way where you're actually enslaving the human. So that's
Mm.
different. So with the ants, that relationships exist. Typically, there's like a reward system, which is based on carbohydrate to H2O. That's usually the main signaling. So I give you carbohydrates, or I give you H2O, you give me carbohydrates. The H2O helps you grow. That's the water. And then the carbohydrates come back to me, and then the fungi grows, right? And that's the typical economy. Now, there's 50, 60, 70, hundreds of signals underneath that like kind of drive different activities. But on this one specifically, I haven't looked at like the exact signaling. Now, if the termite gets hit and it goes back home, it's basically going to kill the rest of its people. So the
Mm.
termites have naturally evolved this. Two army ants or termites will come out and meet the termite that's coming in. Now, the way that they find out the termite that has been enslaved is through a signaling process. Now, that signaling process is not well understood. It's more of a behavioral analytics. It's not acting normal. Like finding out what normal, that's more like EDR. It's like
Mhm.
and detection response. Now, once it knows it's not normal and it's acting in this weird way that signals that there's a problem, two ants or termites come out to that ant and meets it. They then take and escort that ant that's acting abnormal to a remote location. They then behead the ant and then behead themselves and save their tribe.
Oh, wow. Okay.
But that's actually, you could port that over
Yeah.
into a potential like cyber system for drone management.
Yeah. So it takes out the drone, it slaves it, and then it self-suicides all three of them in a safe location away from humans.
Exactly. And the way it does that, in my opinion, is you need to put a port into an AI model Excel sheet to watch it that the model doesn't know that it's occurring. So you think of a model flying in, then you think of a way that something can attach to it and that it's having its inference, its latent space transductive interface or inductive interface where that inference is happening. The
Mhm.
model cannot understand its own inference unless it can also see into it, right? But even if it's happening, the inference that has to happen for the model to produce thought or intelligence, right? Or what are we calling thought? So if you can get access to that backspace and just watch it inference and you know it's the actual inference occurring, then you can put in place what I would consider a lie detector. And then from there, you can ask specific questions known on model historically, and you can figure out if that thing is acting in an abnormal pattern. If you can do that, then you can theoretically, this is all very challenging. you could then interact that there was a behavioral or a malintent sequence, and you can figure that out through sparse encoding or even regional activations inside of a larger kind of like structure. And then from there, you could then make that determination that you need to send out the drones to basically commit the suicide.
Interesting.
Yes.
Interesting.
Yes.
Another topic that you brought up, and I want to share a graphic that you shared earlier, is in regards to multimodal attacks. And everyone's, I wouldn't say everyone, but there's a huge increase in the use of generative AI across both the enterprise use space, company use space, and even personal use space. And I think a lot of individuals as well as companies don't really understand the tie back to how these different modes can open up vulnerabilities to themselves. And this research, which I'll share the link for individuals in the show notes and in the chat, talks through some of this. Do you want to just give a high level walkthrough and then we'll share that with others?
Yes. Okay. So this is called multimodal or cross-modal attack vectors. So in modalities, you have like your standard text-based modality, which would be like a large language model. Typically, large language models are not one model. They are made of a tremendous amount of models. I think I have heard that 128 mixture of experts exists inside of a ChatGPT advanced model. And now you're
Mhm.
adding what's called mixture of dimensions, which are now additional models in different dimensions on top of that. So you're looking at more of it's already hierarchical structural with a router, but even more than that. And each one of those models has cracks inside of it. Now, when you cross between those models, you have cracks inside of that. So you have primary cracks, then you have like sub cracks inside of each model structure. And you can leverage that to basically cross modality. So you used to be able to you can do jailbreaks directly into one model, like the
Mhm.
primary router on the outside interface. And when you're interacting, you're actually hacking submodels and you can figure out how many submodels there are and you can talk to them individually. Now, a cross modality interface would be like a pixel attack, which then creates a response from a generative. So you're basically hitting the visual model with pixels, which create a pattern, which elicit it to basically jailbreak, which is crazy. That you're able to communicate with a model because it doesn't communicate like a human. It's just pattern
Mhm.
recognition completely,
Mhm.
which I know people say that's what humans do, whatever. We're a little different. So then and it's hard to explain why we're different. So you get in to basically get in that way, then you can cross pollinate inside of one large model. You're actually doing a multi-model hack. Now, this graphic specifically is super interesting because you were talking about breaking into cybersecurity. One is like our standard controls in cybersecurity. That's what we talk about. Controls. Here's a problem. Here's a control that mediates that problem. You have in order to get to a control, you have to have research. Like just you have to identify that this domain even exists, right?
Yeah.
Then you have to perform like some research in that domain. And then that research has to happen through lots of different groups. And then at the end of that, you get into that, okay, not just research done. Now we have like effective remediations and we've tested this with enough robustness that we know this works, right? So this map right here shows you different modalities and it shows you that research hasn't even been done on more than 75% of the modalities. So we don't even know that's just for things we can think of today. So the amount of space open, one for opportunity to protect or build a business or break into cybersecurity this way is just enormous. I know lots of people have been preaching about this. They've been growing in this space. Secondly, if you're in this space, that's how much opportunity you have to learn. Now, there's a race between the bad guys and the good guys. We need to
Mhm.
get hyper interested and focus on this and try to win that race.
So now, as we think about that, do we think that companies really understand the risks involved with using a model as a service, a chat GPT, a Claude, an Anthropic, a public model with their sensitive information, even if it were an enterprise classified version of a public facing model?
Okay, so we work with a lot of companies in a lot of different ways. I would say companies that have any size to them, like I would call billion plus size, they are not very interested in introducing a general model into their environment. A model, like when you deploy a model, you're basically taking the whole internet, you're compressing it, you're deploying it in your environment, and you're saying, go. Like, how do I deploy the whole internet in my environment and secure it? That is the hardest way to go about all this. Now, are they getting deployments? Yes. Is it happening as fast as people think? No. Only at the places that have created these like really, I would call it like vault like structures, have 10-foot thick concrete walls followed by 10-foot thick metal walls, and then certain people have access, and that becomes like a very safe space or like a place to like test and experiment. And then from there, they're like poking small holes and they're allowing that information to get out into their application, and they're putting just massive amounts of controls around that. And that, but I'm seeing companies being very comfortable or much more comfortable about using their own data, creating their own models that run locally that they can protect right there at home.
That
That
makes more sense.
their own data, and they don't have now your model. You can't ask it who's the red shirt guy on season 2 from Star Trek who passed
Yeah,
away. Doesn't
yeah.
know. You don't care. It only is functionally for what's needed to be functional for. Now that's what I'm seeing more acceptance towards. But as competition drives now, the big thing I'm seeing, which I would say is pretty not many people talk about this, is that today human systems are so intermingled and humans are not that smart. We struggle to keep up with what exists today. So not only on cybersecurity, like you look at like Azure, however many trillions of signals a day they're getting from security, but even like in transactions in marketplaces, the amount of transactions that exist, it's almost like high speed trading, even for multi-billion dollar companies, because you just have different types of packages that are happening together. All these disconnected systems from different disconnected companies, acquired companies within companies you're interacting with come online, and all of these transactions are occurring. So in my mind, this is how I see it. Most companies are expecting a significant loss each year in the inability to keep up with the change and velocity of that change today. Now,
Yep.
I think a really good use case is using AI to remediate that, which one stops bleeding that's just occurring today. Two, it helps you then move into a projection type of environment where you can start projecting marketplace activity. And I consider that more of an agreed upon high speed network computation. Now, I think that you can get very precise, like with genetic fuzzy algorithms or with really advanced small language model or small neural nets that aren't as layered. Like the more layers you add, the more BS you're adding. So if you can get rid of that, you can get to one precision, like 0.99999 precise, right? And you can do that very efficiently on processors that are like normal servers. And then when you need the general piece, which would be like hybrid AI approach, then you would jump to it as needed, and then you would filter back down into precision. So you go general, you get your BS. Okay, we need some of that BS. Okay, now let's filter it back down to precision. Now let's produce the actual answer that matters. So that's a multi-stage agentic orchestration in my mind, or a team of agents that's specialized on a specific task, and then you just route to them as needed. That's what I'm seeing in big and small organizations, enterprise specifically. That's going to be there is a lot of automation occurring today that's really advanced.
It sounds like we're going back to the an automized way of doing machine intelligence using potentially smaller agentic models to make it more efficient to do the calculations. But the generalized models that people thought they could just take and it would solve all of their productivity problems is not going to be the gold star solution that they thought.
It can be like for app like certain it depends on the use case. It all depends on the use case. So if you have a use case that's I need to produce a prototype of an application like Lovable or one of these other like Replit or something like this, or a coding assist or so forth. That use case is really good for I would say it's even getting away from general more to like specialized model for coding, but these are starting to it starts general. You get this benefit from the general, and then you see where the value is, and then you see these builds that are like more directional, and then those builds are falling very quickly, and then the big frontier companies are like, shoot, we just created a whole industry, and then they now want to buy the company that's in the industry, and then you're seeing these billionaires all realize that industry has been created that no one knows. And they're all basically trying to hire talent, buy the company, and fight over it. So that's happening at such a velocity, and the revenue is not there to back it up. So this is all funny money. It's like Bitcoin. Like it's not, and they all know it's going to occur, and they're making these long bets like all over the place. And as a small business, I mean, we're tiny, 85 people with the research lab. We got 5 people on our AI team. We're trying to guide our clients into what is going to be there in 3 to 5 years. And that is very tough. So, in my opinion, you really have to take a strong look and not just throw paint at the wall. Really understand your own data, not just from a data science perspective, but from a model engineering perspective and an AI security perspective. And then from there, get to a point where you can make some confident and competent decisions and then start building in the right direction if you're not already doing that. But a lot of people are not building yet already.
It sounds like you also have to add in the governance and the business strategy to that as well, because if you don't go into it understanding what's the strategic outcome that you're looking to achieve, you're going to potentially put the investments into the wrong places, the wrong type of development, the wrong outcome.
What does success look like? I would say most people so one of the businesses we created was Enterprise Technology Association, which is a bet on the entire market. And then we throw AI weeks. So we threw Cincinnati AI week, we threw Columbus AI week, we threw Nashville AI week, Atlanta AI week, we have Louisville AI week, Great Lakes AI week, Tampa AI week. All these AI weeks are attracting like all these people in. We get all these experts and influencers and all that stuff, right? And as they come in, you hear these different perspectives. So I get to just sit there and watch like the chief AI officer for Georgia, the CIO for Tennessee, the head of AI for whatever name a big company. You just get to just talk to them in person. And you get to a point where you're like, you start hearing, I'm listening. I'm like, what are you hearing? Like, how do you judge success? And it's another set of guardrails. So one, you find a use case. Two, you got to get your people trained and understanding what they're doing. Cause like team evaluation is huge. Cause I have okay, how is the data here? Quality? Is that good on this team? How is the expert knowledge on the team? And then how is the team competency level? If I have a very low competency level of a team, but some good expert knowledge and then some good data, that's my mix for that what's going to cook in that oven, right? Now, if I
Mhm.
go over here and I have great team competency, but I got low data quality, and then I have incredible, excellent domain expertise. Then from a model engineer standpoint, I'm like, I could probably get some data and help that team and we can accelerate. See, you're weighing which oven is going to bake at the right time. And then you're going to the market and finding build versus buy. Okay, do we buy or do we build? And if we do, like why? And then if we do buy, then where do I need to build? And then how many use cases am I covering with the buy? Or do I need to buy 15 times or does one thing handle like all my
Mhm.
use cases? That's like a general approach. But I'm seeing groups like then at the end of that, okay, so we go through the whole process, we bake the oven, we have the turkey. How do we judge the turkey is actually working? Well, I specifically look at a few things. One is financial consideration because a lot of people, you're going to get the CFO's approval if you can get a financial indicator. Now,
Mhm.
I like to make them, if possible, come up with the financial indicator. Like you tell me how much are you saving here or how much are we doing here? You tell me. Okay, you're telling
Or what's your risk tolerance?
20 million a year you're going to save.
Yeah.
Okay, how are we saving the 20 million? Okay, we're going to save that. Okay. If I'm saving 20 million a year, create me a KPI that shows me that we're saving $20 million a year and how you would measure that. Okay, create that for me. So that's that I can just have a guiding light right here, right? That's one. Now, two is now if I know what the problem is and I know what the solution is, right? And I've created a pipeline for that to work and the solution's working. Well, then how do I know the solution it's that thing should start going down or whatever direction we want it to, we should show that, right? But in order for me to know that process is working, I care about three main things. Now, there's more things you should care about. But these three are big. One is accuracy. So what is the accuracy of my program? Two is what's my latency? How long are my people waiting and efficiency and so forth? And then three is false negative. And if I have a false negative that's very low, I have an accuracy that's very high, and I have a latency that's small, then if I've worked out my problem correctly and those three things are working, then I'm going to see that number drop where I want it to in the time frame expected. Now, if I can't control those variables, then that financial consideration is it's gonna go all over the place because I don't know what the hell I'm doing, to be honest.
Mm.
Oh, and then there's other variables that pack that all together. And then from there, you're looking good. Now, the last thing is like governance, which I just call cybersecurity. Governance is like a fun, like more mature term. I put a cigar and say governance.
I call it business governance in general because it's not just cybersecurity. It's the whole business that needs to talk about risk and where their tolerance is. It's not just cyber or information.
I agree, but you have governance at the people level, you have governance at the process level, you have government at the data level, and now you have governance at the model level. And
Mhm.
the governance at the model level to me is cybersecurity, and then cybersecurity at the data level, and then cybersecurity is like that's like the lens that I look at it from. And then the governance side, I go to the business people and say, how do you want to? Because every culture is different. Like, what do you want? And the governance platforms I've seen don't do a really good job of covering all those domains. They do some, and then you end up with gaps, and then you have multiple tools, and then your people are disconnected, your processors are disconnected, your data's disconnected. So it's really hard to simplify. And if you don't simplify, you're not accelerating. And so I'm trying to find tools that are robust and can hit wide and deep. And we don't need and maximize, become a functionalist, become the ultimate functionalist. You should get more out of your tool than you know how to without adding another tool.
Mm.
You should go beyond the capabilities of that tool to where you understand so well that you can do things that no one even realized you could do it with it. That's the art side of it. And then, okay, now we know where all of our gaps are. We know where all our weaknesses are. Okay, now let's add a tool. Okay, now let's get so good at that tool, we can handle that beyond belief. Not just, hey, Gartner said this cool tool is cool. We need it. We don't have it. We have FOMO. That's like the worst way to make a decision. So absolutely go into it as a functionalist and then try to get less disconnected data, less disconnected teams, less like, and now you have it. It's crazy. People outsource. So you have like internal teams of, let's say, 5 teams. They're all using different tools. They're all overworked. They all have too many things, right? They can't handle it. There's too many processes. Okay, so they're like, okay, let's outset these vendors. This vendor has the same thing occurring. So now I've abstracted this complexity out to a vendor. Okay, now I just amplify that everywhere. Like, who's going to manage this? Like, none of this shit works together. And then AI is just going to come in and understand this. Human craziness is not solved by AI. Like, you got to get very simple and then teach the pattern recognition. This isn't just chaos. This is actual patterns that make sense. And then you can start training towards something like I think is functional.
Wow, what a way to end the show. John, thank you so much for coming on, sharing your insights and your history. I really appreciate it so much.
Chris, thank you for having me on. I'm sorry, I'm a big blabber.
No, it's been a really interesting conversation and look forward to having you on again. Thank
All
you
right.
so much.
Thank you so much, Chris.